somewhat familiar. So determine when to the year, the nearest 0.1 year, the revenue was projected to peak. So this is just a graphing problem. It does say submit your answer in terms of t. That's weird. N of t equals 39t. Okay. So I don't know. Let me. Do you have an example problem?
Let me look.
I want to know if the answer is in terms of t, like if there's a t with the answer. I'm going to check on my side as well. This is from a textbook. So here it just has the answer as just a number. So you have to do these by hand, right? That's what I remember about this? Okay, all right. So let me do this with you. So the derivative here is you have to find the derivative and set it equal to 0.
Okay.
What I'm going to suggest, okay, so we're gonna do the derivative here. So it's the first is the thing I'm going to box in, and the derivative of that, we'll just do that one first. 350. The derivative is that 350 comes with it times 39, and then you keep the second function, okay?
Mm-hmm.
Plus the first function stays the same, e to the minus 0.2t, and then the derivative of e is itself times minus 0.2, and you set that equal to 0.
So you take the derivative and add it to the original?
Well, no, it's product rule, because there's two functions that are you're taking the derivative of.
Oh, okay.
So the derivative, we can review that, but once you have the derivative, you're setting it equal to 0. So the steps here are to factor out anything that's common to both. So like 350 is common to both, and this e to the minus 0.2t is common to both. And then it's like, okay, what's left over? Well, 39 from here plus 39t plus 61 times minus 0.2 equals 0. So this is the part we're solving, setting equal to 0. So this is just these are just steps here. We move the 39 over to the other side equation, and then divide by minus 0.2. So you have 39t plus 61 equals minus 39 over minus 0.2. And then you subtract the 61 and then divide the whole thing by 39. It looks really bad, but this is your answer here. So let me see. Let me get my calculator out and see if I can give you a number for this.
Wait, I think I got lost somewhere. Where did the 350 e to the negative 0.2t, like where did that get factored out?
Those are that was these underlines here. Those are the same in both. So you want to.
Oh no, the second line.
Well, they come from here.
But then, how did you get 39t plus 61 equals negative 39?
So from going to the second line to the third line, you subtract 39. That's where this comes from.
Okay.
And then you divide by minus 0.2. I know you probably would multiply in. I mean, you can do all that. If you have a calculator, I would just have you graph this too, and it'll have a nice maximum somewhere that we're trying to find. It looks like a complicated algebra expression.
Okay.
So if this is like unclear, what you probably should do from the beginning then is multiply in by 350. but it gives you big numbers that you have to work. You have to keep writing.
Yeah.
That's why we didn't do that. So let me get a number. Let me make sure this actually produces a number. It's reasonable. This says 3.4. So could you check that for us and make sure that that is the time?
Yeah, so 3.4 years.
Mhm.
And then it says determine the revenue. Should I just like,
So that's where you take the number you just found, which mine is rounded. I wouldn't want to use that, and you put that back into the original function.
okay.
You put that back into, 3.9 ish. So let me do that as well. So T equals that, and then the revenue is 350 times 39 times T plus 61 times exponential minus 0.2 times T. Okay, so the revenue is 34329. It says round to the nearest 1 million. That means go to the nearest whole number.
Okay. 34329.
Did that work out?
It's loading. Um, the second one did, but A didn't. Is A 3.4?
Yes.
Oh, okay. Then yeah, that works.
Okay. Um,
Okay, so we can move on to the other.
Go back to number one.
Yeah.
Okay. All right. I'm going to have to. Okay. So number one is price elasticity of demand. And let me. Okay. So the price elasticity of demand has a formula. You have to be really comfortable with this formula. It's minus P over Q times dQ dP. Does that look right? Maybe you saw that in class.
Yeah, we like literally just learned this today, so I kind of am like rusty. But yeah, that looks familiar.
Okay, so the we have a lot of the things here. So the 32 is P. Okay,
Okay.
and Q, we get Q from putting this P into there. So Q is equal to 840 minus 20 times 32. So we get a number for that, whatever that is. Okay.
Okay.
And then we have to take a derivative of this with respect to P. So the dQ dP is minus 20. That's just using the power rule.
Okay.
Okay. So so now we just put all this stuff in here. Let me get the numbers here for you. I got a calculator. So P is 32 and Q is 840 minus 20 times P. So Q is 200. So it's minus 32 over 200 times negative 20. Is that clear how we got that?
So yeah, so negative 32 over 200, and then D. Yeah, that makes sense.
Okay, so you multiply all that together and you get 3.2. Okay, so the weekly sales, okay, is 32. So interpret 3.2. Interpret your answer. Now this is the interpretation part. The demand is going, I guess, up is probably the answer by 3.2% per 1% increase in price
Okay.
at that price level. Is that okay? You just take these numbers always match, and if it's
Yeah.
positive, it's up. If it's negative, it's going down. Okay. Now the maximum revenue is price times quantity. There are a couple of ways to do this, but to me, this is the best way. So you take your your quantity function, 840 minus 20p, and you multiply it by price. Okay, and that gives you your revenue function, 840p minus 20p squared. That's your revenue function. To find the maximum, you have to take a derivative. R prime is 840 minus 40p. Set that equal to 0, and then you're solving for p. So you move this to the right side, you get 840 equals 40p. You divide both sides by 40, and you get p equals 21. So notice that that's a different price than the one that's given, and that's fine. I mean, that's what it's, that's what's there. So that's the price. The
Okay.
maximum revenue you get by going back to your revenue equation here and putting in 21. Actually, it's the next line here. Let me do the next line. Oops. So the revenue function when price is 21 is 840 times 21 minus 20 times 21 squared. So let me calculate that for
Is
you.
that revenue function the one we like made, or is that the derivative?
It's the one that we made.
Okay.
It's the original. The derivative just tells you where it happens. The revenue function tells you what is the maximum. And that's 8820.
Okay.
And then we get to repeat with these, meaning we're going to do the same thing again for the next one.
Okay, and then everything was right except it says the demand is going down instead of up.
Okay, so your formula may not have a negative in front of it. There's different formulas here. So price, yeah. Okay, so you say it's going down. I don't know, maybe reconcile that with your instructor. There's different
Okay.
ways of doing this.
Okay. We can move on to number
Okay,
two.
let's move on to number 2. Okay. All right. They give you Q again. They give you P again, and you have to find the price elasticity of demand. So again, we need P. P is 27. Q is 94 minus P squared, but you put that price in, so it's 94 minus 27 squared. And then you need dQ dP, which is the derivative of this thing up here. So that's power rule, 2 times 94 minus P. And then quotient, not quotient rule, chain rule, you have to take the derivative of the inside part. The derivative of minus P is minus 1.
Wait, I'm stuck. How did you do dq dp? Sorry.
So taking the derivative of this right here, of the of Q,
Okay.
and to do that, you apply the power rule first. So you bring the 2 in front, 94 minus P to the power of 1.
Okay.
But then you have to take the derivative of the inside function. The derivative of the inside function is just the derivative of minus P, which is
-1.
negative 1.
Okay.
Okay. All right, and then you're putting the value of P in here to get dQ dP. So it's 2 times 94 minus 27 times -1. So you get these three numbers, which I will give you here. Let me get my calculator out. Price is 27. Q is 94 minus P squared, and dq is what we just said there, -2 times 94 minus P. Okay, so we get 27. This is 4489. This last one is -134.
Okay.
So your E is P over Q dq dp. So that's 27 over 4489 over -134. And again, there's my formula always has a negative in front. I don't know. I mean, we were right on the first answer in the last one, so not sure what to suggest there, but
Okay.
E is minus P over Q times dq. So I get 0.806. And these numbers always match.
Okay.
Okay. So now to me, it should be going up, but I wonder if that, okay, so I think it is negative, but I think because we're on this, I think we're on this side of the curve, and that's why it's going up this time. Whereas on the previous one, we were on the right side, and it's going down.
Okay.
I would probably clarify that with the instructor here. Okay, so let me know when we can move on to revenue.
Yeah, we can move on.
Okay, so I'm just gonna scroll down a little bit here. So the revenue is price times quantity. Our price function is given as 94 minus P squared, and I'm sorry, that's our Q. P is P. So this is what we have to take the derivative of and set it equal to 0. Because we have to find R prime. Now you could just graph this, and you'll find a maximum, but I guess wants you to do it by hand. Are you sure? Do you think your instructor wants you to use it by hand? Do you know if she mentioned that?
Yeah, I think she does.
Okay, because this is there's some other issues here, like price has to be between 0 and 94 because of this part right here. That's a constraint on this, because we're gonna find a function that does a lot of things, but we need to look on this window here. Okay, so the derivative here is it's product rule again. So take the derivative of the first function, 1 times the second, plus keep the first function, and then take the derivative of this, which we've already done up here, but it's 2 times 94 minus P times -1. Okay, so so we're setting this equal to 0. This is 94 minus P squared plus, actually it's minus 2P 94 minus P, and we're setting that equal to 0. So you can factor out a 94 minus P on both. And then you've got one here remaining, so there's a 94 minus P there, minus 2P equal to 0. Okay, so now this left part is 0 at 94 when P equals 94. And then this part is 0, so we got to solve for this. 94 minus P minus 2P equals 0. This is 94 minus 3P equals 0. So P equals 94 over 3. And okay, so that's the price. So we should check that is the one. This one is not correct because it's at the edge of our window. So try this one, and you're going to put that in your calculator. That's That's 31.33.
Okay.
These are much harder to do by hand. If we could graph them, we could just read the answers off the graph.
Yeah, I wish I could. I have to like they make you turn in your work, and if you don't show your work, you don't get credit.
Yeah. I mean, you could show some of this and then you still graph it because it's a lot faster. But if that worked, the revenue function, we go back to it's p times 94 minus p squared. We do it r of this 94 over 3 number. It's 94 over 3 times 94 minus 94 over 3 squared. So let me get that number for you. All right, it's a big number here. It's nearest whole number. So this ends up being 123,049. 23,049.
123,000 what?
049. This number right over here.
0.9. Okay, that part's wrong. 123,049.
Would be demanded. So that's I gave you the wrong thing. So they don't want the revenue; they want the quantity. So that is completely wrong. The quantity at 94 over 3 is that 94 minus p squared. So that's the 94 minus 94 over 3 squared. I didn't read it correctly. It says how many cases we demanded, not what is the maximum revenue. We can calculate that. It's 3,927.
Okay. That's right. Okay, we can move on to 3.
Okay. All right, probably more of the same. Yep. Okay, so this is more of the same. So we'll this will be good because it'll be kind of the same thing we've been doing, but another example of it. Okay, obtain a formula for price elasticity of demand. Okay, so the formula is going to involve P. It's really yeah, elasticity demand of price P. So just as a reminder, it's minus P over Q times dq dp. Okay, so we have the P part, we have P and we have Q. So far it's minus P over, and Q is really all this stuff minus 2P squared plus 30P. And then you multiply it by the derivative of this. The derivative of this at the top, that's power rule, minus 4P plus 30. So if you enter all that in, it doesn't have to be simplified. That is your E. You got to get all that in nicely into the box there.
Okay. Okay, and then compute the elasticity, just plug in 9 for P.
Say that again.
Do you just plug in 9?
Exactly. Yeah, exactly. So because you have the formula, you can just punch it into that thing you put in part A, but you can also calculate the intermediate values.
Okay.
Okay, so I got the price is obviously 9. Q ends up being 108, and dp ends up being -6. So when you calculate the elasticity, I get 0.5 for that.
Wait, how did you get 9 for P?
It's given.
Oh, yeah. Okay, and then
They
Q.
have to give you that value. You can't go anywhere without it.
Okay, and then Q, you just plugged in 9 and you got 108. And then dp dq or dq dp is -6. How did you get the -6?
That's this part over here when you put p in.
Okay.
So I'm trying to give you the individual values, but you can also, just put it right into this formula to get the value.
Okay, so it's 0.5. And then,
So there's this thing where the elasticity curve where at the top here it's 1, and if it's on this side, I think it's 0. It's 0.5 is on this side, so that's why I think it's going up this time
okay.
versus this way, which would be coming down. But these numbers always match.
Okay. And then for C,
Yep, it says maximum daily revenue. So revenue is price times quantity. So that's price times, and then we got to grab our formula for quantity, -2p squared plus 30p. And this time I'm going to multiply ends because there's no exponent here. So it's -2p cubed plus 30p squared. And then you want to take a derivative. Your derivative is -6p squared plus 60p equals 0. Just power rule, nothing too much there. You might think to move things around, you actually just want to factor here, and you can factor out a -6p from both, and that gives you p -10. And then, so you set each of these equal to 0, and you end up that p is 0 or p is 10. Now, 0 is kind of ridiculous because you don't want to do that, but they tell you up here that price has to be between 9 and 15. So the one that's going to work is going to be the one between there.
okay.
So the price should be 10. Now this time it is asking for revenue. So you are finding revenue of 10, which is 10 times -2 times 10 squared plus 30 times 10. And let me get that number for you. So revenue, price is 10, revenue is price times -2 times p squared plus 30 times p. That's 1,000.
Hold on, I think I'm confused. Oh, so 10. Where'd you, like, it says 10 times -2.
Well, I'm putting it into this formula here. This is the revenue formula. Or this one over here also would be the same.
Okay. So P. And what did you say the answer was?
1,000 is the revenue.
Okay, So 10.
Did all that work out?
So the t-shirt is going down, and then the elasticity formula is wrong, but I could have typed it in wrong. So I put negative p over negative 2p squared plus 30p times 4p plus 30.
This part isn't really kind of in the numerator. It should show as being just to the right of it.
Yeah, it is to the right of it, but should negative p, should it not be negative p?
Maybe not. I mean, that would be worth trying.
Okay. Okay, that's wrong. I don't know why it's wrong because it's like typed in exact.
Yeah. Maybe ask your instructor what they say. They might simplify. I don't know. You can factor out a p, and you can so you can. The simplified version of it is this p cancels with each of these, and that negative goes in. So it'd be like 30. I'm sorry, it'd be like 4p minus 30 over minus 2p plus 30. I mean, you can do some more simplifying there. If there's a C another or C a, usually it doesn't care if you don't simplify, but if there's like a C similar, let me you'll see maybe it's simplified in there. Let me get you the third a simplified version though, so you can decide if that's what's wrong. It could be the negative. um, okay, so I get if a simplified version is 15 minus 2p over p minus 15.
15 minus 2p, p minus 15. Yeah, that's right.
Okay, so there it does need a simplified version. All right, let's go look at.
How did you simplify it?
Um, I can do that down here. It's so we have minus p over minus 2p squared plus 30p times the derivative, which is minus 4p plus 30 up here. So like the bottom here can be rewritten as I can bring this minus, so it's minus p on top. On the bottom, you can factor out a minus 2p, and you get p minus 15.
Mm-hmm.
You can also factor a minus 2 out of, or a 2 out of this. So that gives you minus 2p plus 15. And then these all cancel. And that's so you get 15 minus 2p over p minus 15. Yeah.
Wait, yeah, go back. Okay, so negative 2p and negative p times 2 cancel. And then, okay.
Is that okay? Can we move on, or is there explain that a little more?
No, that makes sense.
Okay.
But I think we skipped number 3.
The demand,
Yeah.
it's either up or down. I still don't really understand that, but these numbers always match.
Oh, no. Number 3. Like, this is number
Oh,
5.
question 3.
Yeah.
Oh, well, it isn't appearing in this list.
Oh, it's not?
I don't see it in this list. Now, let me just look. I nope, I do see it, but it for some reason it didn't. It didn't. Like it didn't generate an image file, so it came up. I see it now. I'm back to the email and got it. Okay. Hopefully it's big enough to see. It's really well. You've already got it. So okay. Find the price you charge to maximize revenue. Revenue is price times quantity. Price times 86 minus 2p squared. The derivative is needed. So there's two functions. There's the first function and then there's the second function, or u and v, product rule. The derivative of the first is 1, and then you keep the second, 86 minus 2p quantity squared. Plus, keep the first, take the derivative of this. The 2 has to come out in front, 86 minus 2p to the power of 1. Then you have to take the derivative of the inside function, which is minus 2. So let me just rewrite this a little bit. This is 86 minus 2p squared. This minus 2 goes with this 2 and this p, or this minus 2 goes with this 2 and this p. That's minus 4p times 86 minus 2p. We're setting this equal to 0. So what you can do is you can factor out an 86 minus 2p because they both have one. There's still one left over here. And the only thing that's left over here is this minus 4p. You set this equal to 0. So these both get set equal to 0 though. 86 minus 2p gets set equal to 0. And then this one also gets set equal to 0. The 86 minus 2p minus 4p gets set equal to 0. When you solve this one, p is 43. And when you solve this one over here, you end up getting 86 minus 6p equals 0. P equals 86 divided by 6. And this one, if you put this back into the revenue function, R of 43 will end up equaling 0. So we know this one's not it. Now you're supposed to do a second derivative test, but I mean, you've done enough here, and usually the instructor's okay with this. This is the price where the maximum occurs. So just punch that into the calculator and see what we get here. That's 14.33.
Okay. We can move on to number 5.
So this is exactly the same as the other ones, meaning we have to find the price elasticity of demand by using the formula. But here they just want a number, so that's nice. So this is the price, that's P. You get Q from up here, and then we have to take a derivative, but we can do that as well. So the price is at 38. The quantity is 439 minus 38 over 150 squared. So we'll get that number. Then we have to take a derivative of this. So let's just rewrite it slightly. It's 1 over 150 times 439 minus p squared. This 1 over 150 is just a constant. It just comes with it. dq, dp. So that 1 over 150 just comes with it. This 2 comes in front though. That's power rule. 2 times 439 minus p. And then you have to take it to the inside part, which is -1.
Wait, I think I'm lost. So how did you get? So why does it say Q equals 1/150? Like
Well, that's
I'm
this right here. That's just rewriting it in another way.
okay.
The 150 on the bottom can be brought out in front as a fraction, 1/150. It's easy to think that this is quotient rule, but it's not. It's just a number in front. It's the same as if it said 150 in front. It's
Okay.
a constant.
Um, and then dp dq
The
is
QDP is the derivative of this. So the constant just comes along, and then we have to take the derivative of what I've circled, and that's what's that's this part here. Power rule. You're bringing the 2 down. The 2 comes in front. Keep the inside part.
okay.
Multiply by -1.
Okay.
Okay, so then we put p into this function and we get a value. So we get dq, dp, and we get a number. So let me get those numbers. I always encourage you to try these as well, just to see if you're getting the same numbers. Whoa. All right. All right. So I get Q is like 1072.0067, and then
I got
dq.
that too.
I'm sorry.
I got that too.
Great. And then this one is minus 5.3467, roughly. Okay, so then elasticity is minus p over q times dq dp. So we're just taking these numbers we just found, minus 38 over the 1072.0067 times the minus 5.3467. And I get 0.20 for that. We should probably check that because there's everything a lot of went into that.
Yeah, that's not right.
Okay. Price is 38. 439 minus p squared over 150. And then the derivative of that is minus 2 over 150. Oh, 0.19. I'm sorry, I rounded
Oh,
incorrectly.
okay.
Uh, that is
Um,
enough. That is enough to see a difference.
okay, yeah, that's correct.
All right. So the revenue function, revenue is
Wait, can you go back up? I just need to I need to write, yeah, right there. Just the elasticity equation.
okay. Just a
Is
reminder, I'll send this out afterwards with the PDF of the notes and the screen recording.
okay. Okay. Yeah. Revenue. I'm good to move on.
Okay, so revenue is price times quantity. And I keep saying that because it's got to be really clear for you. The
Yeah.
price is the variable. Q is given. It's the 439 minus P squared over 150. I'm going to just slightly rewrite this. P over 150, 439 minus P squared. So our prime is, okay, we're going to take the derivative of the first. 1 over 150 is the derivative of P over 150. And then you keep the second function. Plus, keep the first function, P over 150, keep it as is. Then take a derivative of this. The derivative of 439 minus p all to the power of 2 is power rule. You're going to bring that 2 out in front. 439 minus p power of 1 times -1. So let's just clean this up a little bit. It's 1 over 150, 439 minus p squared. This -1, this -2 makes minus 2p over 150, 439 minus p, and we're setting this equal to 0. That's just a cleanup step. It's not really much going on there otherwise. So now you got to figure out like what is common in both. So there's always a GCF that you can factor out, and that's what we're doing here. Greatest common factor. So the 1 over 150 is in both because there's a 150 on the bottom, 150 on the bottom. They both have a 439 minus p in them. This one has 2. This one has 1. Okay, and this is, since we're factoring out a GCF, it's like, well, what's left over? And even if you don't quite understand everything here, like you're going to see a pattern, like it always is the same, always the same. So like what's left over? There's a minus 2p here on the right. If you multiply in, you get back to the previous line.
Okay.
Now we've been setting both of these equal to 0. It's always this one that you set equal to 0. This middle one is the one that ends up working out. So this is 439 minus 3p equals 0. So p equals 439 divided by 3. And that's 146.33.
Okay.
So that's letter B. Let's make sure that's correct.
Yeah, that's correct.
Okay, so last thing, again, revenue. We have the price, so we're putting that back into the line up here where we've got the revenue. Didn't copy real well. Revenue is price times this, so we're putting this number we just found in for P.
Okay.
Both of those. So I got a calculator here. Let me do that as well. And I get 83560. This is round to the nearest dollar.
83560. Okay. Okay, that's correct.
Okay, this is a great place for us to stop. Like I said, I'll send out the notes and the screen recording here shortly. Thanks again for scheduling, and I'll be happy to help next time.
Thank you. Have a good night.
Welcome. Bye now.
Bye.